Hi everyone, I'm Yifang Li and my co-author Dr. Kelly Caine from Columbus University. Today I'm going to present our paper about evaluating the performance of obfuscation for social media photo privacy protection. We all share photos on our social media when there's a milestone in our life that we really want to celebrate with others, like I completed my PhD or my kid's first day at daycare. Or after we traveled somewhere, we took great photos that we want to share with our friends. So there are a huge amount of photos that are being shared on social media every day, every minute. For example, people share more than 200,000 photos a minute on Facebook and nearly 47,000 photos a minute on Instagram. They all have all kinds of visual content, including the sensitive content. We had another paper in Caine 2020 that talks about types of sensitive content in people's photos that people consider sensitive. For example, I'm sharing a photo of my friends, but their identities could be compromised. Or I really want to share my photo. Everything looks good, but I'm just not satisfied with my facial expression. Or share a photo of the workplace, then realize there's something inappropriate depicted. So there are news that people got fired because of these photos, but they shared without even realizing this could be sensitive. And I really want to show off my cute puppy, but I don't want others to see that I have a tattoo on my arm. It's kind of personal, and I don't want to show that side of myself to others. And also, it's personal identifiable information that the strangers can track down. It's me in the photo, and he's my dog using this tattoo information. So what can we do to alleviate this kind of privacy leakage? What Facebook currently offers is just recipient selection, meaning you can choose to share with all of your Facebook friends or a group of friends or exclude certain friends. However, it's not effective and also not usable. Aside from recipient control, in another paper, we proposed and evaluated different types of obfuscations that control the content of the photo. For example, we evaluated the commonly used obfuscation like blurring, pixelating, and also evaluated some novel ones that we proposed like avatar and inpinning. So avatar here is the cartoon sticker applied to the sensitive content, which is my tattoo here. And inpinning just completely removes the tattoo. So our prior work shows that avatar and inpinning are the two most promising obfuscation methods that have both good effectiveness and good user experience. But in that paper, we only studied obfuscation standalone, didn't integrate obfuscations into a social media photo uploading system. So we needed to find out whether these obfuscations reduce privacy concerns. So in this paper, we proposed an obfuscation system that is integrated into Facebook that keeps the recipient selection feature, but also added content flag, which means the system automatically detects the sensitive content in a photo and then provide obfuscation. So how it actually works, once users upload a photo, the system detects the sensitive content and brings it to users' attention. Then it provides a few types of obfuscations like blurring, pixelating, and after inpinning, but users could also choose no obfuscation and post it as is. The last step, same as the current Facebook feature, it has the recipient selection. Remember that the goal of this study is to evaluate the performance of obfuscation integrated in Facebook photo uploading system. So in order to evaluate that, we included the other two conditions in our study. The first one, we included the original Facebook photo uploading interface as control that allowed us to see whether there was a significant drop in user experience in our proposed obfuscation system. In the second one, we included the content flag condition that only has the recipient selection in the content flag features with no obfuscation. We included this condition to control for the possible experimental confound of highlighting sensitive content, just to untangle the effect of the content flag feature from the obfuscation feature. And last, the third condition in our study is our proposed system, which has all three features. So our research questions are first to understand whether our proposed obfuscation system reduces users' perceived privacy concerns and increases the willingness to share compared to the content flag system. So that's the performance of obfuscation. And second, understanding whether our proposed obfuscation system maintains the same level of usability compared to the original Facebook interface, because we do not want to harm users' experience because of adding our privacy features. And also we want to know whether it performs better than the content flag condition. The study has two steps. The first step, we collected photos that people really wanted to share on their Facebook but didn't share due to privacy concerns. So we use these photos as stimuli in the second step experiment. In total, we collected 998 photos. We did an analysis on the types of sensitive content. So this is actually one of the contributions of our paper because we tested and amplified the sensitive contents taxonomy from our prior Caine paper and created this one that has a larger number of data points. Of all of the sensitive content categories, these three are the top categories of content where people wanted to share the photo on Facebook but didn't because of that information. So for step two, 152 participants returned to the experiment, and we randomly assigned them into the three experimental conditions. And based on the research questions, we had a set of metrics. The dependent variables include perceived privacy risks, willingness to share, ease of use, and overall system satisfaction. So from the results, we found that with the content flagging privacy enhancing feature added, the interface performs worse than the original Facebook photo uploading interface in terms of perceived privacy risks, willingness to share, and user experience. As you can see on both bar charts, there are significant drops for the content flag condition compared to the original Facebook condition. So this actually makes sense because users were notified of the potential privacy risks, but they were not provided with effective tools or solutions. But if we look at the bars of our proposed obfuscation system, we will find that it actually repairs the harms of content flagging that we just talked about and restored privacy risks, willingness to share, and user experience back to the levels of the original Facebook interface. So it performs a lot better than the content flags interface. So from this, we can say that our proposed obfuscation system is a success. That's all for my talk. I want to thank NSF for funding this project, and thank you all for listening.